So this is a assignment regarding membership. So this is customer segmentation machine learning model which I have built. So first of all, we import the libraries, pandas, scikit-learn, Plotly. Then we read the dataset. This given. We have all the field customer ID patterns, purchases. So we start with the data processing. First, we see the different values such as the count, standard deviation, max, and the median values. So we find that there are many that the max value is not very much than the median values. So there is a chance that there will be outliers in this data set. So we drop the customer ID first example we use. Then we drop that particular row of where the credit limit is severe. It's not because there's only one row and removing the row, it's that will not cause much loss. The minimum payments, there are some null values, so we replace that with the median value of the minimum payments. So that the we plot the different columns. We find that various columns are skewed. Some skewed columns have values rather than 100,000, much more, and some columns are there which are value 0 to 1. But more or less, every column is skewed. So we need to deal with this skewness and also have to deal with outlier, which are much like here in the credit limit, there are some values that 80,000. To deal with this, there in the balance, there is some which are 20,000 purchases that are around 50,000. So to deal with this. So first we see the correlation in various columns. Correlation plot, we find that the purchase frequency, different purchases like one-off or installments are correlated among each other. So first we remove the outliers. So before we impute the outliers, we need to remove those values which are outliers. So we take the 25th percentile and the 30th percentile, find the IQR, which is the difference among them, and we take the mean value and max value of every for sure for every column, and we remove whose values are less than the minimum value and max value, uh, and replace those with NaN. After that, when we have the NaN values, we compute those with the gain imputer, which takes the neighboring values, takes takes the neighboring values and average them and assign them to the values. After that, we need to transform the values. We need to deal with skewness. So we take the quantile transformer because it is robust to outliers. Also, previously we have dealt with the outliers still. We can use the quantile transformer. Also, we can produce dot transformer. So here for the values which are larger values, which are for the columns which have values like around hundreds, thousands, which are in the limits of hundreds and thousands, we transform those by quantile transformer, and for the values which have and for the columns which have values between 0 and 1, we should use a dot transformer. After that, we pass all these the pipeline. The pipeline we give the dot transformer for these particular these particular columns because there are values between 0 and for the quantile we assign the columns which are in the hundreds and thousands. After that, we scale it using standard scaler from the scalar library. And here we find much of the skewness has been removed. Still, there are some, but also most of the columns are having the values between 0 and the division 1. But then we perform the dimensional reduction. So we experiment these with various. First of all, we need to experiment with different number of components, but we need to find the optimal number of components for which variance will be maximum. So when we plot the expected variance and the cumulative variance ratio, we find that for n equals to 6, we are having maximum cumulative, like it's having the most of the cumulative variance. Actually, in the data set, there are 17 useful columns. From there, we are making dimension reduction. We can use this. We can use 6 components, which will have the most of the variance of the data. So we take n components as 6 and we perform the PCA. So here there are 6 principal components. Now we need to do the clustering. So first we will do the k-means clustering, and for that we will do hierarchical clustering. So first we need to find the optimal number of k. So for that we need to do the algo method. We have done, so for every we have taken 10 clusters maximum. From there we need to find the optimal cluster number. We have used k-means plus plus, which is slightly better than k-means. In the algo method, we find that the best value of k is 6 because the WCSS value has an elbow around 6. Now we will be plotting the slough score, slough plot against different clusters, or like different n clusters. So for n cluster equals to 2, we find the slough score is 0.3379, and we have found till n cluster equals to 7. So here we find that n cluster 2 is having the maximum slough score 0.33. After that, n cluster equals to 6 is having the majority, like second maximum slot score. It is 0.3178. In cluster equals to 2, it's having the uh, majority maximum slot score, but it's not uh, of any use because that will be having uh, just 2 clusters, and in customer dataset there will be having various types of clusters. So we take the second best slot score, that is 0.317, and take the cluster 6. So we have plotted the slot. We have plotted the slot against all the clusters. For cluster equals to 4, we have the slot score is 0.30. If we take the n cluster equals to 6, so here all the clusters are evenly distributed, and also we can see we can visualize the clustering of the data here. So now we take the n cluster equals to 6 and perform the k-means. We have assigned another column into the data called k-means cluster, which will be having all the data regarding the. So it will be giving the cluster value to every row. So from here we find these. Here we find the box plots. So if we analyze those, we find there are 6 types of customers. One, there is less balance, makes more purchases, high purchase frequency, and less takes less cash advance. So for cluster 0, we can offer rewards for a higher purchase frequency because they are having the highest purchase frequency, and we can encourage them to, perform purchasing also as well. For cluster 1, we can offer like financial education for credit use because they are taking more cash advance rather than purchases, and also they are having lesser credit limit, making less payments. So we can give them more financial education or proper financial planning and increasing the purchasing frequency. Cluster 2 customers having more balance, more moderate purchases, like they are making both one-off and installment purchases as well. Also, they are taking cash advance or to credit limit. So their profile is much more balanced. We can offer strategies like balance credit, balance transfer promotions, provide tiered reward based on spending, reduce premium card upgrades, and higher limits. So likewise, there are customer with cluster 3, cluster 4, cluster 5. So total 6 types of customers. And here we find cluster 5 are having high balance. They are only making cash advances rather than doing any purchases. So we can impose more competitive rates on the cash advances. And we also can provide uh, any financial education to those customers for debt management. And now we have performed the hierarchical clustering. So here we have also plot the distortion score. So here also we have find the elbow curve method. We have also used the elbow method. We have found that the optimal value of k is 8 here. Likewise, we have also plot the sellout plot and have also visualize the clusters. So here for n plus 2, we find sellout score is 0.34. For 3, it's 0.309. For 4, it's 0.27. Cluster 7, it's 0.27. For cluster 8, it is 0.29. Cloud analysis for parallel clustering with encapsulates of 4. So there are 4 evenly distributed clusters, but we need to see the cluster number 8 because WCSS curve has a elbow around cluster number 8. Here, the cluster 8, and we can visualize the different clusters formed here. We have taken 8 clusters and plot the box plot. We have formed the 8 different type of customers and provided different type of strategies here. Similar to the k-means clustering, we have also made the given the profile of the different customers and also possible strategies for better marketing purposes. Thank you.